Oxygen is the chemical element with the symbol O and atomic number 8. It is a member of the chalcogen group in the periodic table. A highly reactive non-metal, and an oxidizing agent that readily forms oxides with most elements as well as with other compounds. After hydrogen and helium, oxygen is the third most abundant element in the universe by mass. At standard temperature and pressure, two atoms of the element bind to form dioxygen, a colorless and odorless diatomic gas with the formula O2. Diatomic oxygen gas currently constitutes 20.95% of the Earth's atmosphere. Though this has changed considerably over long periods of time, oxygen makes up almost half of the Earth's crust in the form of oxides. Dioxygen provides the energy released in combustion and aerobic cellular respiration. And many major classes of organic molecules in living organisms contain oxygen atoms, such as proteins, nucleic acids, carbohydrates, and fats, as do the major constituent inorganic compounds of animal shells, teeth, and bone. Most of the mass of living organisms is oxygen as a component of water. The major constituent of life forms oxygen is continuously replenished in Earth's atmosphere by photosynthesis, which uses the energy of sunlight to produce oxygen from water and carbon dioxide. Oxygen is too chemically reactive to remain a free element in air without being continuously replenished by the photosynthetic action of living organisms. Another form of oxygen, ozone, strongly absorbs ultraviolet UVB radiation, and the high-altitude ozone layer helps protect the biosphere from ultraviolet radiation. However, ozone present at the surface is a byproduct of smog and thus a pollutant. Oxygen was isolated by Michael Sendiver just before 1604, but it is commonly believed that the element was discovered independently by Carl Wilhelm Scheele in Uppsala in 1773 or earlier, and Joseph Priestley in Wiltshire in 1774. Priority is often given for Priestley because his work was published first. Priestley, however, called oxygen dephlogisticated air, and did not recognize it as a chemical element. The name oxygen was coined in 1777 by Antoine Lavoisier, who first recognized oxygen as a chemical element and correctly characterized the role it plays in combustion. Common uses of oxygen include production of steel, plastics and textiles, brazing, welding and cutting of steels and other metals, rocket propellant, oxygen therapy, and life support systems in aircraft, submarines, spaceflight and diving. One of the first known experiments on the relationship between combustion and air was conducted by the 2nd century BCE Greek writer on mechanics, Philo of Byzantium. In his work Pneumatica, Philo observed that inverting a vessel over a burning candle and surrounding the vessel's neck with water resulted in some water rising into the neck. Philo incorrectly surmised that parts of the air in the vessel were converted into the classical element fire and thus were able to escape through pores in the glass. Many centuries later, Leonardo da Vinci built on Philo's work by observing that a portion of air is consumed during combustion and respiration. In the late 17th century, Robert Boyle proved that air is necessary for combustion. English chemist John Merrow refined this work by showing that fire requires only a part of air that he called spiritus nitroaereus. In one experiment, he found that placing either a mouse or a lit candle in a closed container over water caused the water to rise and replace 1/14 of the air's volume before extinguishing the subjects. From this, he surmised that nitroaereus is consumed in both respiration and combustion. Merrow observed that antimony increased in weight when heated, and inferred that the nitroaereus must have combined with it. He also thought that the lungs separate nitroaereus from air and pass it into the blood, and that animal heat and muscle movement result from the reaction of nitroaereus with certain substances in the body. Accounts of these and other experiments and ideas were published in 1668 in his work Tractatus Duo. In the tract, The Respiration, Robert Hooke, Ole Boch, Mikhail Lomonosov, and Pierre Bain all produced oxygen in experiments in the 17th and the 18th century, but none of them recognized it as a chemical element. This may have been in part due to the prevalence of the philosophy of combustion and corrosion, called the phlogiston theory, which was then the favored explanation of those processes. Established in 1667 by the German alchemist J. Beecher, and modified by the chemist Georg Ernst Stahl by 1731. Phlogiston theory stated that all combustible materials were made of two parts. One part, called phlogiston, was given off when the substance containing it was burned, while the dephlogisticated part was thought to be its true form. Alcohols, highly combustible materials that leave little residue, such as wood or coal, were thought to be made mostly of phlogiston. Non-combust